IBM Power Systems ASP Auxiliary Storage Pool. This is presented by Gajapathy Pathy. In IBM Power Systems ASP Auxiliary Storage Pool, configuration involves segmenting the Direct Access Storage Device (DASD) into multiple storage pools to manage disk space, mirroring, and backup policies independently. Here's an overview of ASP configuration on IBM Power Systems. Determine requirements. Before configuring ASP, assess your storage requirements, including capacity, performance, redundancy, and backup policies. Identify the applications and data sets that will be stored in each ASP and their respective importance to the business. Partition DASD. Use IBM I commands or management tools to partition the DASD into separate ASPs. Each ASP is assigned a unique identifier and allocated a portion of the total disk capacity. You can configure ASPs with different RAID levels and mirroring options based on your requirements for data protection and availability. To partition the DASD into separate ASPs, you can use the CRTASP Create Auxiliary Storage Pool command to partition the DASD Direct Access Storage Device into separate ASPs. This command allows you to define the characteristics of each ASP, including size, RAID level, mirroring options, and backup policies. Here's the basic syntax of the CRTASP command. SPDV specifies the name of the auxiliary storage pool device ASP device. This is the identifier for the ASP. DV specifies the name of the DASD device to be partitioned into the ASP. PTUSD specifies the percentage of the disk capacity to be allocated to the ASP. The remaining space on the disk is left unused. You can also specify additional parameters to configure mirroring options, backup policies, and other ASP attributes. What is RAID levels? RAID is a data storage technology that combines multiple physical disk drives into a single logical unit for the purposes of data redundancy, performance improvement, or both. RAID levels define different configurations or layouts for organizing data across multiple disks, each offering different benefits in terms of performance, fault tolerance, and capacity utilization. Here are some common RAID levels. RAID 0 striping. Data is distributed evenly across multiple disks without redundancy. Offers improved performance by allowing data to be read from and written to multiple disks simultaneously. No fault tolerance. If one disk fails, data on all disks is lost. Typically used for applications where performance is more critical than data protection, such as video editing or gaming. RAID 1 mirroring. Data is mirrored across two or more disks, providing redundancy. Offers high data availability and fault tolerance. If one disk fails, data can be retrieved from the mirror. Read performance is generally similar to a single disk, but write performance may be slower due to the need to write data to multiple disks. Requires twice the storage capacity of the original data. RAID 5. Data is striped across multiple disks with parity information distributed across all disks. Offers improved performance and fault tolerance. If one disk fails, data can be reconstructed using parity information. Provides a good balance of performance and capacity utilization. Requires a minimum of 3 disks and can tolerate the failure of one disk without data loss. RAID 10. Combines RAID 1 mirroring and RAID 0 striping. What are the options of mirroring? When it comes to mirroring in the context of RAID, redundant array of independent disks, or disk storage, there are several options available, each offering different levels of redundancy, performance, and complexity. Here are some common mirroring options. Disk mirroring. Disk mirroring, also known as disk-to-disk mirroring or volume mirroring, involves creating an exact copy of a disk volume on another disk. This is typically done at the operating system level rather than through RAID hardware. Provides a simple and effective way to create backups or ensure data redundancy for critical volumes. Can be implemented using built-in features of the operating system or third-party software solutions. May not offer the performance benefits of hardware RAID mirroring but provides a cost-effective solution for small-scale deployments. Network RAID mirroring. Network RAID mirroring involves mirroring data between storage systems over a network connection. This allows for data replication and redundancy across geographically dispersed locations. Provides disaster recovery capabilities by ensuring that data is stored in multiple locations. Requires high-bandwidth network connections and specialized storage solutions capable of synchronous or asynchronous replication. Offers scalability and flexibility for organizations with distributed data centers or remote offices. How to configure mirroring for ASP. Configuring mirroring for an auxiliary storage pool (ASP) on IBM Power Systems running IBM I involves several steps. Mirroring provides redundancy and data protection by replicating data across multiple disks. Here's an overview of how to configure mirroring for an ASP. Identify disks. Ensure that you have at least 2 physical disk units (DASD) available to use for mirroring. These disks should be of the same size and type to ensure optimal performance and compatibility. Check disk status. Display hardware resources or work with disk status. Initialize ASPs. Initialize them using the Initialize auxiliary storage pool command. Backup configuration. It's important to regularly backup the configuration of your ASPs, including mirroring settings, to ensure data integrity and disaster recovery preparedness. Configure mirroring. Decide whether to configure mirroring for each ASP to provide redundancy and data protection. Scale and expand. You can scale and expand ASPs by adding additional DASD capacity or reconfiguring existing ASPs. Next, IBM I performance monitoring tools for ASPs.